Hello, and welcome to AWS Review, a weekly look at what's happening at AWS and how it may change how you do business. I'm your host, Michael Krause. I am the Chief Technology Officer at Charter Solutions, where we help organizations change and innovate quickly by accelerating their acquisition and use of data.
And I'm your co-host, John Affolter. So I'm a sales engineer at Charter Solutions, and here I help potential customers in helping them envision the possibilities that AWS enables.
Excellent. Well, John, this is our first episode, and I'm sure people are noticing I'm having technical difficulties already. So, par for the course when people are starting things out. Are you excited?
Oh, I'm super excited. And yes, it always in the demo, and I guess that's the power of real-time data, I guess.
Absolutely. And I think this is probably also partially me shooting myself in the foot. If you notice, my background is different today.
Yep.
My wife and I decided to shift our offices around in the house in the weekend, and I probably should have done a bit more testing before I went live after the office shift.
Hey, you
But
know what? That's what we deal with every day with clients. So
absolutely, absolutely. And just for anybody who might be tuning in or listening to this as a restream, we will be looking for guests in the future. Topically, we're going to be talking about all things AWS and how it relates to real-time data, how it relates to data processing in general, and how we can leverage the data that we're processing in customer-facing applications. So anybody who's listening, who's interested in being guests, feel free to reach out to us. Both mine and John's Twitter handles are available on the screen, and we look forward to talking to you.
yeah, I know. I know that you wanted to kind of talk a little bit about the spring weather here a bit, but I don't think that's happening quite yet here in Minnesota. So
Yeah, Saturday it was a real nice, almost 60 degrees. We actually got out and did a little yard work. And then I wake up this morning and there's snow on the ground again.
it's like the false winter is, or the false spring is what I keep hearing it being called. So I'm excited, but
I tend to follow the Lord of the Rings style and call it second winter.
yeah, that's absolutely, absolutely. So, but yeah, I mean, I know that we got a lot of really cool stuff to talk about today. I wanted to, before we get into the old topic of the day, which is real-time data in AWS, I wanted to take a quick look at kind of what's been happening with AWS over the past week.
Excellent. So one of the things that I saw come out of AWS in the last week that I was excited about was an announcement around AWS Lambda, and they have now released the ability to add more ephemeral storage to your Lambdas, up to 10 gigabytes now. And of course, they're charging for anything over 512 meg, but that is a significant limit. And I'm excited about it because I've had a number of clients that I've been working with who need to process some large chunks of data. And one specifically who had a piece of code they needed to run, but could only run as a command line option. So they have to write a file out to a file system, execute a command line on that file. And a number of the files were way bigger than what Lambda could handle. So we had to go down the path of attaching, elastic file system shares onto the Lambdas. And then we were dealing with issues of if you use on demand, we were running into performance issues because they only allocate bandwidth based on how much you store. And then the cost of that to do provision starts becoming fairly expensive. So this provides a real nice kind of option for those people who need to do those types of things.
Yeah, no, absolutely. I think, just the power that it gives for, machine learning and be able to run inference, I think is going to be a big game changer. And, like you said, it really helps make things a lot more agile, and you're not having to set stuff up, individually. So I think it's kind of a paradigm shifter with a lot of different architectures.
Yeah, it is. It is. So it opens up a whole lot of new stuff, especially if you followed one of the announcements not too long ago, where you can now inject a Lambda into the process flow of getting data from S3.
Yeah.
You can actually make gets invoke a Lambda so that when we're feeding the data back, you can actually process that data on the flow on the fly. So this gives you better temp storage if you need to grab a copy of that file, manipulate it into a different copy, and then send it out, and you don't want to do all of that in memory.
Yeah, I think that's a game changer, especially as you're starting to work with a lot more different types of files, and you're trying to combine those. And as you have experience with, Michael, kind of, working with audio files, text files, moving those to different types of files and combining those and running machine learning on those
Yep,
in concurrency.
exactly.
I know that Proton came out and they announced that they have support for Terraform, the open sources. It's not generally available right now, but they do have a an update on that. And obviously, I think any time that you can implant Terraform with AWS managed services, I think that you're really extending the ability for AWS to be kind of the center point of a multi-cloud type type distribution. I didn't know if you had any thoughts on that at all.
Yeah, I think this is a big one. I tend to lean towards CloudFormation when I'm working with an all AWS type solution. But there are a number of companies out there who, for various reasons, have selected Terraform, and Terraform is a great tool. It's a powerful tool, whether you're just doing AWS or if you're running multiple clouds. So the fact that Proton now supports Terraform, I think is a very good move forward, and it opens up use of Proton to a much larger a group of people out there.
How do you feel? The Proton. Just kind of the usage has been, or have you seen it much in the market yet, or do you feel like it's kind of just, starting on the cusp of it?
I think it's early right now for Proton. People are evaluating it. Um, I think you'll see probably more adoption to people who are new to AWS or building greenfield solutions.
Mhm.
Whereas I think organizations who have existing platforms, it's a little bit more of a path they have to go down to
Mhm.
switch over from what they're doing today over to something like Proton.
Okay, so yeah, really makes a lot more sense for that greenfield instead of trying to refactor a bunch of stuff that you might already have created.
Right. But one of the things that I typically recommend to customers is that they're constantly updating their technical debt. Everything's changing all the time, and there's always better ways to do it. Don't let yourself get locked into an old way. So as you're looking at, where do you go next? AWS Proton should be one of the things that you're actively evaluating and saying, all right, now that this is available to us, does this give us better operational advantage, better development advantage, better cost management advantage? Any of those types of things.
Yeah, and I think just anything that improves the agility of your teams and lets you be able to push out features a lot quicker is going to be something that can really enhance your ability to stay, keep that competitive edge. And
Yep.
I think that's a good segue into our topic here that I'll let you introduce of kind of real time and how that's competitive edge. So.
Sure, absolutely, absolutely. So let's go ahead. Then we'll move into our kind of topic of the day, which is real time data on AWS, and this is kind of a broader topic initially. In the future, we'll do some deep dives into specific areas. But we wanted to introduce the concept because we feel it is a growing concern, a growing need, and people need to understand what does it mean and how does AWS fit in general. Today it's just John and I chatting about it. In the future, I'm going to make the call out one more time. People who are interested in participating and being a guest on one of our topics, please reach out to us. We would be happy to entertain that.
Absolutely. So yeah, Michael, I guess I'll start by asking you, what do we mean when we say real time data? So I guess there's a lot of places that can go.
Yeah, absolutely. And real-time data can mean a lot of different things. And I'm just going to share a little something here real quick. This came out of Forrester. And it's taking a look at the time that that you the timeline within which you get your data and the value it makes to certain types of decision making. And it's really good to look at this and kind of think about, things that you're pulling in on a monthly or daily basis don't help you make decisions on things that are happening during the day. And as companies continue to move down a path of joining the cloud, getting more competitive in that marketplace, being able to make fast decisions is really important, right? And if you look at online retailers, their ability to take a look at what you've been looking at, what you've placed in your cart, things like that, and make immediate recommendations is just one approach to how you can take and do immediate decisions and actions based on data. But what's more interesting in this, in my opinion, is that when you take a look at the technology that you roll out in an organization to implement this, data processing, data ingestion, data delivery, actions upon data, when you start moving into the minutes, seconds, and what we'll call true real time, where you're responding to things like in an IoT world where something happens and you have to make a change right away, the technology that you're using shifts, right? Mm-hmm. So your old, I'm going to go and do an extract from a particular system, run an ETL batch that translates that and loads that into a data warehouse, and you're going to do that, every night or once a week or something like that. That can't support the fact that you might have thousands, tens of thousands, hundreds of thousands of devices, systems, services, customers that are doing things and delivering data in real time or near real time that you may need to be able to process and act upon in situ. So you're acting upon it as part of the collection and response of that data, or act upon it operationally so that you are looking at it even throughout the day, what's happening, right? And taking actions on those things. Now you're talking about technologies that ingest that data, process it, deliver it, and act upon it more as a stream, especially if the data is coming from a location that's different from an app itself, right? To have an app that collects the data and acts upon it's one thing. To have, 1,000 devices out in the field that are delivering information, and based on that information, you may decide whether or not to roll a truck to fix something. That is a totally different stream of data and processing of data, and the technologies are different.
Yeah, no, absolutely. And, there's also the element of, real time versus near real time. And
Yep.
It's always a big question of mine, kind of where that line in the sand is between that and making sure that you're optimizing for obviously a response, but also what is the throughput and kind of making sure that your costs are kept optimized.
Right. So, let's talk about that edge, right, of real time versus near real time versus I'll just call it near time, right? So if you really want to be absolute about the definition of real time, we're talking about millisecond or microsecond response. Mm-hmm. We're talking about I've gotten a piece of data, and based on that piece of data, I have to make an immediate, extremely fast response, right? So this traditionally has been the world of process controls in manufacturing. Yep. Right? I have a plant, I have conveyors, I've got motors, I've got things, and when certain things happen, I may need to slightly tweak the speed of a motor or something like that in response to something, and that has to be done very, very quickly, right? That's typically happens within the realm of a specialized process control computer. When you start stepping out of that, now let's take a look at IoT for an example. Mm-hmm. In IoT, you might be looking at, in agriculture, you might be looking at sensors that are checking soil moisture content. and sending that back across an entire farm, right? And you might need to make a decision of, do I turn on my sprinklers?
Yep.
Now, that decision may not just be based on moisture content,
True.
right? It could be based on a combination of moisture content, prevailing weather, right? If I have a thunderstorm that's really about to hit me, do I really want to turn my sprinklers on, right? Time of day. I may say, well, it's better to water in the evening twilight hours or in the morning twilight hours. And therefore, this portion of my field, which tends to have higher runoff, I've got lower moisture content happening, in the middle of the afternoon, right? So
Yep.
I may now say, I'm going to make a real-time decision or a near real-time decision on that to schedule my sprinkler to go on in that area this evening, right?
Yeah.
So that's real time and near real time. And then near time starts getting into, rather than making decisions now, whether in microseconds or milliseconds to seconds, to now we're starting to look at minutes, right? So now I can handle a little more latency. And this is where, if you look at AWS and the technologies they provide, right? I can set up, and I'm going to continue to use IoT as an example here because it gives a lot of breadth on this. I could set up a system where I'm pulling in sensor data and it's being transmitted all the way to the AWS cloud. And when that comes to the cloud, I can then run some processing on it and make some decisions. Now, if the timeliness of those decisions don't require a lot of a lot of immediacy, I can then make those decisions every 5 minutes, every 10 minutes if I want to, which means I can collect that data, batch it up, and with better cost efficiency, usually, I can run what we term a micro batch. It's not a large set of data; it's a small set of data, but I'm batching it into chunks so that I can get some efficiencies and economies of scale in processing it, and
Yeah.
then I can respond that back, right? I could also build a streaming data solution where as the data is coming in from those sensors, I'm evaluating it independently and acting upon it right away. Now, we're not talking millisecond, microsecond response all the time there because you have the latency of the network, you have the latency within AWS, you have latency of your code and what's operating, but it's much faster than what you could do normally today. If I have an entire field in my go offline, I could pick up the fact that I haven't received the data, process that, send an alert to somebody to go out and figure out why that went offline, see if there's something going on over there. Has somebody come and pulled all my sensors? Did we lose power to something and the battery backup gave out?
Yep.
But taking the AWS example one step further, with Lambda at Edge and AWS Greengrass and even the Snowball family tools that support Lambda out in the field, you've got now a number of options where you can push processing down to the physical location.
Yep.
And in that scenario, now the data comes in, it goes to something that is physically nearby. So you've got lower latencies, and you could make decisions there and act upon those decisions and then send back to the cloud. Here's the data I've been collecting. By the way, here's also the decisions I'm making.
Yes.
Right? So now I've gotten even closer to real time, but I've also provided feedback up. So whether I'm running static or code that I've written, or I'm leveraging machine learning models that I've pushed down to those devices, I have the ability to take that and basically reinvent, recreate, retrain, optimize and push those optimizations back out so they can be applied locally again. So that was kind of a long-winded answer.
Yeah, no, I mean, you brought up a lot of really good points and a lot of interesting things about the paradigm of real time and where you process that data because, to your point, you can have something out at the edge that's doing things in real time and maybe you have a probabilistic and a deterministic pathway of your data that
Yep.
says, hey, maybe if it hits a certain threshold, then maybe we go up for some more computing on a larger set of data or looking at other trends or to your point as well, is combining other aspects. So, hey, maybe there's a thunderstorm coming in and you don't need to water the grass, and or you have your dad yelling at you, never water the grass during the day because it's going to
Yeah.
spoil the grass.
Never water the grass in the heat of the sun.
That's the real time I know that you can go off of too. But you bring up another point too, is the difference between real time and near real time. And I guess my question is how do you approach the customer of understanding where that trade-off is, and maybe it's a value versus a perceived value type of conversation, and kind of walking through those different decisions on seeing what is needed to be real time and what's near real time too.
Yeah. So what I'll do is, yeah, I'm going to reshare this again.
Yeah.
And what I've seen, yeah, and this is a great tool to look at. This is it's not whether or not the data could be real time.
Yep.
The question is, what is the optimal time frame, both for execution of what you're trying to do and potentially for competitive advantage, to make those decisions in, and specifically to focus on actionable decisions, right?
Mm-hmm.
I could connect up to a system with hundreds of thousands of sensors all over the world. I could collect all that data real time, and I could store it in a data store where I could query it and analyze it, and then I could never use it.
Mm-hmm.
And that is a terrible waste of money.
Yes.
Right? Now, at the same time, I could say, well, I would really like to be able to leverage that data to help me plan my next product iteration, my next piece of hardware I'm going to build. Because that's really good data in determining failure rates, how it's being used, all of that kind of stuff. But when you're planning a new hardware product, your time level is months to years, right? So incurring more cost to gather that real time, if you have an option to grab it in batches, I would do a nightly upload of data if it can cache it that long, is valuable. Now, as you push your time frame to action on this further to the left, then now you're looking at, all right, what is the appropriate time frame to act, right? If I'm trying to turn on a sprinkler, well, maybe that time frame to action needs to be a second or two, right?
Yep.
If I'm, I'm not going to name names here, but, one of the things that we do at our house is we have, these video doorbells and video cameras, around, around the house. And, if there's movement, lights go on and I get notifications on my phone letting me know something's going on. Well, in that scenario, I'm delivering a service, or they're delivering a service to me to let me know that somebody's in my yard, somebody's doing something, and the time frame for me to be able to take action on it is now, not when they've already left. So now we're looking at, okay, here's a customer need, safety and security, to be able to understand what's happening right now, and to be able for that customer to react to it and make that. So now we have actionable information, and now we have a time frame that to make it valuable to the customer, I need to know within a second or two that something's going on.
Yeah. No,
so driving from that perspective, don't drive from the data and how fast you could consume the data, but drive from the actions that you or your customers want, and use that to drive how you consume that data.
Yeah, and you bring up a really good point, and something I know that you're really good at looking at and planning out with certain customers is how does this how are you ingesting data to match up to your product roadmaps, and making sure that you're doing the things now in a cost effective way so that you're able to act quickly when you do want to implement that product feature that might have a real time element to it. Talk to me a little bit about some of that roadmap planning, and and maybe even some of the things that you've done with other clients that might be novel, or looking at how you process data in real time that has different workloads coming, firing off in parallel too.
Right. So I think, a couple of things. Let's start with the product question.
Yeah.
It's a soft question because it depends on the organization, right? So if you look at the technology adoption curve, most organizations can be placed on that technology adoption curve based on how they adopt technology as a company, right? Are you an early adopter? Are you early majority? Do you tend to wait until it's become the thing and then you adopt it, right? So you're the late majority or a laggard. So that's the first thing, is to understand, one, where are you? And understand, two, whether or not that's the right place for you, for your product, right? Competitively, it's like there's that famous statement that Snapple's goal is to be the number 3 beverage. They're not going to try. They don't want to try to kick Coke and Pepsi out of the numbers 1 and 2 spots. They want that they want to own that number 3 spot, right? That's their target, right? A lot of people will be like, well, why don't you want to be number 1? Oh, well, they can make a whole heck of a lot of money at number 3 and not spend a lot of money trying to make number 1 happen, right? So, if you're a laggard, there may be value in you being a laggard. If you're a late majority, but you might look at it and say, the way things are going, we need to make a shift as an organization from late majority to early majority on our product strategies, or even late majority to early adopter on some subset of our product strategies.
Yep.
So that's the first place to start. Understand what you're kind of where you are in how you invest in technology and bring it to your marketplace, because that can bring different competitive differentiation in. Once you've got a good base understanding of that, now you can start looking at what's going on in the market. What are your customers asking for? What technologies are coming to the fore? The art of the possible part of it, that before we couldn't do. So a lot of the things that we talk about with regard to IoT and with regard to real-time data processing or near real-time processing or near-time data processing comes back to technologies. 10 years ago, it was very, very expensive to do a lot of this stuff. I often, you've heard me tell this story as well. I often talk about, I did a big project doing IoT, doing analytics, doing machine learning, rolling out predictions of test results that could only be tested in a lab based on real-time data and all of this stuff. And I did this in the late 80s. We had no cloud. We had to install a network in the plants. We had to do a lot of that stuff. There was a lot of cost and a lot of heavy lifting to get that return. With AWS, what's happened is a lot of this stuff has been brought and almost made commodity. So things like, where am I going to store all this real-time data? We've got time series databases, we've got S3, we've got Redshift, we've got lots of places where we can store this efficiently and access it effectively. What are we going to do with regard to processing and reacting to the data in real time? Well, we've got things like Kinesis Analytics and stuff that just are available to just turn it on, do some work, and boom, now you've got a stream of data coming through that you can react to. Super easy these days. So the enablers, seeing those enablers and strategically planning around those enablers to say, okay, where can I get a leg up? What are my customers saying? Oh, boy, I wish someday I could do this. Can I bring that to them sooner? Which would put me in a different position with them relative to my competition.
Yeah, and I think you bring up a good point, is all of the planning and all of the implementation that you would have to go through just to maybe have something that would work. And I know that, when I first came to Charter, I was kind of a Kafka fanboy, and introduced me to all the different AWS tool managed services, and really kind of told me about, what are the companies really want to focus on, and focusing on those differentiators. And it really gives the ability to fail fast and not have to spend time provisioning and having a huge internal, learning curve, and really kind of accelerates a lot of that future development.
Absolutely. Absolutely. Well, John, we have reached end of time here for our stream for today. We're actually a few minutes over, which, not too bad for our first try, but I think there's a lot more topic here to talk about. And I think we'll be planning a future stream to dig a little deeper into real-time data as a concept. And kind of the strategic initiatives and strategic implications of that.
Yep.
So let's offline pull that together. But for the audience who's joining us today, I'd like to thank you all for joining us and putting up with my terrible audio video disconnect. I will have that fixed for next time. We hope you learned something new today. If you liked what you heard, please subscribe to our channel so you'll know when we have our next live event. And then join us next week at the same time for our next fun and interesting topic.
Yeah.
Thank you all.
See ya. Thank you all.
All right.